Hello AP, this is part 3 of chapter 2.8, naming acids. Okay, so with acids are probably the hardest type with naming for students. And we got to be really good with naming acids because we got two chapters called chapter 16 and 17 that we name acids for. So naming acids, let me get my pen going. Most of the time acids begin with that hydrogen. Okay, so whatever's in back of it, it could be a nonmetal, it could be a polyatomic. So we're talking about no metals absolutely in here. So naming acids, unfortunately, there's a couple rules that go with it. Okay, so I put rule number 1, 2, 3 here, and we'll take it nice and slow. Even gave you some examples. So if you have what's called a binary acid, so the word binary acid has a H and only one nonmetal in the back. Now you already know hydrogen's +1. Now that nonmetal has to be a negative with some type of charge. So with acids, the hard part with acids is it's molecular because you're talking about hydrogen that's a nonmetal and a nonmetal bonded to it. But you also have charges thrown in it too. So you got a little bit of ionic in here too. So you got to name it and also keep track of charges, like molecular versus ionic. So the first rule is if we have a binary acid, we have an H and one nonmetal in back of it. So when the name of the anion, remember the anion's the negative charge, ends in IDE, we add a prefix called hydro to name the hydrogen, and then we change that IDE to IC. So as you see from the rules, whatever the nonmetal's name is, we change the IDE and we call it hydro, whoever the nonmetal is, and then IC at the end. Now we do need a second word for acid because it is an acid. So if I had chlorine, then I would take that IDE off, name the hydrochloric acid. Okay. Now, if you have something with a subscript, so maybe like a H3N, that N came from nitrogen because originally it was H plus and N -3. So when you crisscross, then you get H3N. But it doesn't matter about that 3 when you name it. It's still hydro. And that nitrogen came from nitride. So you take that IDE ending off and put IC, so nitric, and then the word acid. Okay. These two rules are if you have polyatomics, okay? But it's the polyatomic endings that can change the rules. So if I have an ITE ending versus an ATE ending on my polyatomic, then I have one of two endings that changes, okay? So if I have a polyatomic that ends in ITE, and remember ITE means it has less oxygens, then I'm going to take that ending off and add my new ending called OUS. And here's the key part also. We don't name hydrogens when it's polyatomics bonded to it. Okay? So it's like you pretend like the hydrogen is not even there, but we only need the hydrogen to remind us that it's an acid. So whatever the polyatomic is, ITE becomes polyatomic OUS acid. So for example, if I had ClO2, and that should be a -1 on the top. Sorry, it's at the minus is on the bottom. So that's chlorite. I take that ending off, and now I have the formula HClO2, and it's called chlorous acid. Okay, because the H was +1, ClO2 was -1, electrically neutral, chlorous acid. And once again, we don't name the hydro. Or if I have a polyatomic with ATE, I take the ATE off, add my new ending of IC. Once again, it's a polyatomic, we don't name the hydro. So if I had ClO3 -1, and I'm going to bond that to hydrogen, electrically neutral, then I get this formula HClO3. And I take that ATE off, and I add IC. So I have chloric acid. Notice the 3 with chlorine. I have Cl- hydrochloric. Polyatomic with 2 oxygens, chlorous acid. polyatomic with 3 oxygens, chloric. Do not confuse this first one with this one, okay? One has hydro, the other one doesn't. And when you have hydro, that means it's only H and 1 nonmetal. If it doesn't have hydro, that means it comes from a polyatomic. So before I do some examples with you, I have this little flow chart to help you, okay? So first question to ask yourself is, do you have an anion, a negative ion, that has oxygen? So more specifically, do you have a polyatomic? Okay, so that, sorry, I didn't mean to write the word oxygen, but that oxyanion. Okay, do you have a polyatomic that has oxygen? And if you do, this is the polyatomic side. And if you don't, then that means all you have is a nonmetal. So H, hydro, nonmetal, IC ending. But if you have a polyatomic, you got to check the ending to the polyatomic. ITE, OUS. ATE, IC. So it's a quick little chart to help remind you of those. Now, I do have a beware here, okay? We do get a little crazy with spelling when it comes to elements, okay? So let me give you an example. With sulfur and phosphorus, there are 2 letters that have to get added back on when it comes to spelling, okay? So I'm going to show you some examples right now, and I'm going to show you why those 2 spellings are really important, okay? So let me go ahead and do a sulfur one first. So if I have this one versus this acid versus this acid, sorry, SO4, okay? So these 3 are different acids. They all begin with hydrogen. One of them's a nonmetal. The other one has a polyatomic. And the other one has a polyatomic too. Okay? So, rule number 1. I see H and 1 nonmetal. So in this case, I'm going to name that hydro. But because these 2 are polyatomics, I'm not naming the hydro. Okay? Now, this right here, S, comes from the ion called sulfide. So what's going to happen is, if you notice sulfide, remember the beware on sulfur, the UR is kind of gone with that ion. So when you name it as an acid, when you drop that ending, you got to add UR back on. Because when you actually say it and then you look at the spelling, if you don't add that UR back on, it doesn't look like the way you're saying it. So we name the hydro, IC at the ending, and then obviously the word acid. Hydrosulfuric acid. Okay, so you got to add the UR on. No matter what sulfur it is, polyatomic, nonmetal by itself, you always have to add the UR back on. So this one, SO3, comes from the polyatomic sulfite. And this SO4 comes from the polyatomic sulfate. Okay, so check out that ending, ITE. And remember with polyatomics, we don't name the hydro. Okay, so we take the ending off, but we got those 2 new letters we have to add back on. ITE changes to OUS. So I'm going to add that UR back on. And for sulfate, take that ending off and add a new ending called IC. So if you notice that first acid versus this last acid, hydrosulfuric, sulfuric. One's polyatomic, the other one's not. Okay, so these are 2 completely different acids. With the phosphorus one, real quick, with phosphorus is a -3. Okay, no matter what, if I have this acid with phosphorus or just the acid with phosphorus by itself, you still have to add those 2 letters back on. So you have to add OR back on. So let me show you how it looks. Phosphorus as an ion is called phosphide. And where the OR needs to get added back onto it, it's phosphide with the OR. So I'm going to name the hydro because it's an H and a nonmetal. But those 2 letters that I put back on are right there. And then IC at the end. Okay, so hydrophosphoric acid. And for this one, I have a polyatomic. And this polyatomic is called phosphate. because it has more oxygens. And with those more oxygens, I'm not going to name the hydro, but I'm going to take that ending off and put IC, but I still have to add those 2 letters back on. So it almost looks like this first one. Sorry, had a little moment there. Okay, so phosphoric acid. Okay, but, oops, sorry. When you get to spelling, I want you to see the difference in the ending. Oops, before I get to hydrates. When you have this polyatomic, that's ITE. And notice just the element. If I ask you about the element of phosphorus, well, when you spell the element that's on the periodic table for phosphorus, it's only US at the end. But what if you were naming an acid that's PO3 and you have that ending of ITE? Well, we don't name hydrogen still. Okay, we have to add those 2 letters back on, OUS. Okay, so remember with its ITE, you add that ending OUS. So please make sure you see the difference between the element phosphorus and phosphorus acid. They are 2 different ones. Hopefully, ladies and gentlemen, this helped you on acids, and you know we're going to practice. But acids are very important in chemistry. 2 huge chapters coming our way, probably the 3rd term, chapter 16 and 17, all about acids. See you on the next one.